In today's lesson, we'll be learning how to solve equations that have radicals in them. We'll be mainly concentrating on when you have a square root in the equation, but they don't have to limit it to just equations that have square roots. It could have a cube root, it could have a fourth root, a fifth root. And so before I even begin, remember a radical looks like this. It's got your root in it, okay? And so when it's written like this, that's a square root. If you had a little 3 in the check mark looking thing, that's a cube root. And then kind of continuing on with that, that would be a fourth root. If there was a 5, it'd be a fifth root, so on and so forth, okay? So the one that we're going to concentrate on today is how to solve an equation that has a square root in it, and the x is in the square root part, okay? So the thing that you have to remember is when you have a square root in an equation, if you have to get rid of it, remember you have to do the opposite of whatever's being done. So the opposite of square rooting something would be to square the root, okay? And that'll actually get rid of it. So then the opposite of cube rooting something would actually be raising it to the third power, or in other words, cubing it. And then if you had a fourth root, then you would have to bring it to the fourth power to undo the root, okay? So what we're going to talk about is just do a couple examples with how to actually solve these equations. So there's two main steps to solve the equation. All right, so we're going to write down our steps first. So the steps. First, if you have a radical in the equation, the first goal is you have to get the radical alone. In other words, you have to isolate the radical, get it by itself. So that's your first goal. And then once you get the radical and whatever is underneath the radical alone, then you do the opposite of whatever the radical is. And so in our case, because these problems that we do will have a square root in it, then we'll be squaring it to get it away. And so remember, if you square one side of the equation, you have to square the other side. You have to, what you do to one side of the equation, you have to do to the other. And so after that, you just square both sides so that you can get the radical to go away. All right, so let's do an equation or do a problem so that you can see what I'm talking about. So let's say that you have 2 plus 3x minus 2 equals 6. And actually, it's, 2 plus the square root of 3x minus 2 equals 6. So if we had to solve this equation, notice you have an x underneath a radical, okay? So when that's happening and you have to solve the equation, so the directions here will say something like solve this equation, that means at the end of this, you should have x equals and then have an answer, okay? So the first step, you've got to get the radical alone by itself. So notice you have the square root and then all of this is underneath it. And you have to get that, it's on the left side of your equation, you have to get it by itself. Well, notice it's not by itself because there's a 2 being added to it. So what you want to do is get rid of the 2. Well, the 2 is being added to it, so you do the opposite. So you'd have to subtract 2. And so when you do that, the 2 minus 2 is 0, so it goes away. And then this plus sign, you could kind of drop 2 because this is essentially like a positive 1 in front of that. And so that's not really going to change anything. So it just comes down. You're going to bring down the square root of 3x minus 2. And then on the other side, well, 6 minus 2 ends up being 4. Okay, so now you've got the radical alone. So to undo the square root, because you want to get rid of the square root, you've got to do the opposite of square rooting, which would be squaring it. So we square that side of the equation. And then what you do to this side, you also have to do to the other side. So we would have to square the other side of the equation. So when we square the square root, they are opposites of each other. So they're going to go away. And then we're left with 3x minus 2 on this side And then 4 squared ends up being 16. So now notice, once you do this, then it's pretty easy. You just solve this equation like you have solved equations in a bunch of your other math classes. So we got to get the x by itself. So I'm going to add 2 to both sides. So then these go away. And then I have 3x equals 16 plus 2, 18. And then you've got to divide by 3 so that the 3 is no longer with the x. And then 18 over 3 is 6. So now, after you finish this, you're going to find out for sure tomorrow, because we will continue these notes tomorrow, that is very important to check your answer. So all you have to do is take what answer you get and plug it back in and make sure that it works. So if I take the 6 and I plug it back in, I'm going to be plugging it back in for x. So it'd be 3 times 6, which is 18. 18 minus 2, that would be 16. And then I square root it. So when I take the 16 and I square root it, I get 4. And if I add 2, so I got to add it to 2, I should get 6 out of it. And so because 2 plus 4 is actually equal to 6, that means that 6 works out in my equation. So that is the correct answer. Okay, let's do another one. So let's say that we have 3 times the square root of x plus 3 equals 15. All right, same thing as before. You've got an x underneath a radical. So to solve that equation, you've got to get the part that's underneath the radical by itself, or I guess the radical part by itself. So now you've got a 3 being added and a 3 being multiplied times it. You always start with the adding and subtracting. So I'm going to subtract my 3 so that it'll no longer be on the same side as the radical. So those will go away. So then I have 3 times the square root of x on this side equals 15 minus 3 is 12. And then from there, well, you still have it being multiplied by 3. So to get rid of the 3, you've got to divide because that's the opposite of multiplying. And then these would go away. So I have square root of x on this side, and then 12 over 3 ends up being 4. So now we have our radical by itself. So the opposite of square rooting is squaring. So to get rid of the radical so that that radical is no longer over the x, we square it. And then what we do to one side, we got to do to the other. So square both sides. The square will cancel out the square root because they're opposites. So I end up with x equals 4 squared, which is 16. And then just like before, take your answer, plug it back in and make sure it works. So if I take 16 and plug it in for x, and I do this to it, I should end up with 15. So let's see. 16, when I plug it in, it'd be the square root of 16, which is 4. So we get 4 here. And then that'd be 3 times that. So 4 times 3 is 12. And then I have to add 3 afterwards. So let's see, that was 12 plus 3. That ends up being 15. So that checks out. So that actually works as my answer. Okay, let's do another one. Just trying to get you a bunch of examples here. Okay, so let's say that we have the square root of x plus 3 equals 5. Okay, so when I solve this one, notice this one is kind of nice because if you look at the left side of this equation that has the radical part is already by itself. And so we don't technically have to do this first step here just because the radical is already alone. So now we can just go ahead and move to try to get rid of the square root. So the opposite of square rooting is squaring. So I'm going to square, and I have to do it to both sides to keep it balanced. So the square root and the square will cancel because they're opposites. So I'm just left with x plus 3 on this side. And then 5 squared ends up being 25. Okay, and then from there, we just have to solve for x. So because we're adding 3, we've got to subtract it to both sides. And when I subtract it, I end up getting x equals, and then 25 minus 3 is 22. And then we just plug it in to make sure that it actually works. So when I plug 22 back in, 22 plus 3 is 25. And then when I square root 25, I end up getting 5. So that works. So you could put a little check mark next to each problem so that you know that you have kind of verified that it actually works as the solution, because tomorrow you'll find out that not all the answers that you get will work. So you definitely want to check them. All right. Let's do one more, and then hopefully you guys will be set for the problems. Okay. So let's say that we have the square root of 6 minus 3x minus 2 equals 0. All right. Notice the radical is not by itself. So you're subtracting the 2 here. So you've got to add 2 to get it away. And notice, remember, you do it to each side of the equals mark. Put your little wall if you need it. Okay. So the negative 2 and the 2 will cancel. And then I'm left with the square root of 6 minus 3x. All of that's under the radical equals 0 plus 2 is 2. To get rid of the square root, you square, and you have to do it to both sides. The square root and the square will cancel. So on this side, I'm left with 6 minus 3x. Goodness gracious, love my lead. Ooh, buddies. All right. And then equals 2 squared is 4. All right. So now this equation is a little tricky, so be careful. Notice this negative 3 is being multiplied times x, and then this 6 is kind of being combined. It's actually a positive 6, so it's actually being added to this side of the equation. So to get rid of it, you actually have to subtract 6 to both sides. Okay, so that's the tricky part. So 6 minus 6 is 0, and then you're left with negative 3x on that side. And then on the other side, you have 4 minus 6, which is negative 2. Okay, and then from there, you're taking negative 3 times x, so you have to divide by negative 3 to get it away. And so negative 3 over negative 3 is 1, so they'll go away. And then negative 2 over negative 3, the two negatives make a positive, so then you get x equals 2/3, okay? And then you can plug it back in. When you plug it back in, if you need to use your calculator, you can, but you'll notice when you plug it back in, the 3 and the 3 on the bottom of that fraction will kind of make it go away. So you'll be left with a negative 2. So it'd be 6 minus 2, which is 4. And then you square root 4, you get 2. And then 2 minus 2 is 0. So that checks out as your answer here. So that would work for